Hi there, Algebra 2. 11.3, probability on multiplying events. Students will be able to find the probability of the event A and B. Students will be able to find the probability of event A or B. Dependent events. Two events are dependent in the occurrence of one event affects the probability of the second event. So, for example, if let's say I draw something out of a hat. Okay, we're drawing names out of a hat. Alright, I draw the first name. Well, the second time I'm going to go in there and I didn't put the name back in. Well, now I can't get that name. My probability is going to be different. It's going to change depending on the person I pulled off the first, whether who I can get the second name. Independent events is when the outcome of one event does not affect the probability of the second event. The two events are independent. So, that would be kind of like, let's say I was drawing out of the hat and then the next time I was rolling a dice. Okay? Mutually exclusive events is when two events cannot happen at the same time. Maybe I say numbers greater than 100 that are prime. Well, there should be no numbers above 100 that I am aware of that are prime numbers. Even I believe 101 should be divisible by something. That one might get me in trouble. Okay. Let's say all even numbers above 100 is greater than, or all even numbers greater than 100 are prime numbers. Well, automatically you know that there's a 2. Because I don't want to go with 101, like I said, I believe could be also possibly prime, so I don't want to go there. Okay. So, classifying events. Are the outcomes of each trial dependent or independent events? So, first one, rolling a number cube, then spinning a spinner. They have nothing to do with each other. So, this would be an independent event. Because it doesn't matter what number I roll on my dice for what I'm going to get when I spin. Pick one flashcard, then another from a stack of 30. Well, more likely, whether I replace it or not, and usually if I replace it, I usually throw it on the bottom, is it going to matter? Well, unless you put it exactly back down, you're probably not going to get that card again. Therefore, this one would be dependent. Okay? You select a coin at random from your pocket. You replace the coin and select again. So I drew a coin out of my pocket, and then after that I put it right back. Does that make it? Well, the first time, maybe my odds were 1 in 6. Well, when I replace it, it's still going to be 1 in 6 to get that one. So this one would be independent because we replaced. Okay. Nothing too hard so far. Now, if A and B are independent events, the probability then of B and A is B times A times P of B. Alright, so basically probability of P and A is going to be equal to probability of A times the probability of B. Alright, at a picnic, there are 10 diet drinks and 15 regular drinks. There are also 8 bags of fat-free chips and 12 bags of regular. If you grab a drink and a bag of chips without looking, what is the probability you get a diet drink and fat-free chips? Well, diet drink is going to be 10 over 15. Alright? And so there's 10 out of the 15 drinks that you can grab. Alright, now on the fat-free chips. Fat-free was 8 out of 20 different options. Alright, multiply across, or you could have reduced this, so this would be 2 over 3. And this, I can take a 4 out, which would give me 2 over 5. Okay, multiply that, I'm going to get 4 over 15. So the probability of this happening would be 4 out of 15. Which also you could change to a percent if you want it, or leave it like that. What is the probability that you will get a regular drink and regular chips? Well, regular drink would be 5 over 15. Because we have 5 out of a total of 15. Regular chips is going to be 12 over 20. Alright, times them. Like I said, reduce this down would make multiplying easier. So you're going to get 1/3. You can take a 4 out of that. That's going to get me 3 over 5. Multiply, you should get 3 over 15, which is 1/5. Which would give you about a 20% chance of this happening. Okay. Mutually exclusive events. You roll a standard number cube. Are the events mutually exclusive? Rolling an even number and rolling a prime number. Okay? Prime. So, is there a problem or a number that would be happening? Well, you have 1, 2, 3, 4, 5, 6. Alright. So, 1, we need the even numbers though. There's 1 is gone, 3 is gone, 5 is gone. Okay, is 6 prime? Well, 2 times 3, so no, because it's not just 1 and 6. 4 is 2 and 2, that's not prime. 2, that's 2 and 1, yes, it's prime. So, this one is not mutually exclusive. Okay? Rolling an even number and rolling a number less than 2. Okay, even number, and it's going to be less than 2. Well, the only number on the cube that's less than 2 is 1. And is it even? No. So this one is mutually exclusive. Okay? Alright, the probability of A or B. Probability A or B is equal to P of A plus P of B, which is probability, minus the probability of A and B. If A and B are mutually exclusive events, then P or AB equals PA plus PB. So, when you just have to add this. Alright, so now, going into this one. At your high school, a student can take one foreign language each term. About 37% of the students take a Spanish. About 15% of the students take French. What is the probability that a student chooses at random is taking Spanish or French? First thing you need to think about is, first off, is this mutually exclusive? Well, it says you can only take one, so yes. Well, the probability of one, which is 37, is going to be added to the probability of the other, which is 15. Those two together equal 52%. Okay? Now, in problem 4, about 9% of the students take Chinese. What is the probability that a student at random is taking Spanish, French, or Chinese? So, we add this together, and then we add another 9. So we get 61% of the students would be taking at least one of these foreign languages. Once again, it is mutually exclusive, so that's going to happen. Finding probability. Okay. How many options do I have here? Suppose you select a token at random from the dish. What is each probability? The token is square or red. It's got an or in there. Alright, so probability of, or chances of getting things is 9. Okay? square. Let's go square root first. 1, 2, 3. Being red, 4, 5. So I have a 5/9 chance of that happening. Now, the other one is, the token is green or square. Well, green, 1, 2, 3. Alright, 4, 5. So once again, I have 5/9 as my probability here. There is your homework. It's actually got the wrong page.